Hello friends, today I'm going to explain to you the concept of binary operations. Let us see what are binary operations. If you have two objects, say A star B, the star thing which you put in between, that is called as an operation. Now this operation can be anything. That means you have two objects. Operation can be simply adding the two numbers. That's called as an operation. Or if I put another operator, this is called as an operator. It can be subtraction. It could be anything pertaining the two objects. It could be A multiplied with B square, or it could be A to the power of B or B to the power of A. Finally, you are operating on these two objects, and that is called as an operation. Now, how do you check whether something is a binary operation? For it to be a binary operation, they would have given a certain set. Now, after performing the set, if the output, this is called as an output, if the output also belongs to the original set, then it is a binary operation. What does that mean? Let us take a simple example. Imagine I have a set of natural numbers. N is equal to, say, 1, 2, 3, 4, and so on. This is an infinite set of natural numbers. Now, when you take n cross n, this is going to give me a set of all ordered pairs like 1, 1, 1, 2, 1, 3, and so on. A set of infinite pairs, ordered pairs. Now imagine I have a certain operation on an ordered pair. A star B, I say, is A plus B. This is how I define. We want to check whether this operation is a binary operation or not. To check that, take any ordered pair. Say for example, I take 1 star 2, I get 1 plus 2, I get 3. Now observe that this does belong to the original set n. This is the original set n. Let me show you the original set n in red color, natural set of natural numbers. So if you take any ordered pair, say for example, I take 5 star 7, I get 5 plus 7, which is 12, which belongs to, again, a natural number. Hence, the operation star is a binary operation. Now, if you are getting an ordered pair which does not belong to that set, then it is not a binary operation. For example, now you follow this arrow. Suppose I have an operation A hash B, and that I am going to take as A minus B. Let us see whether this operation is binary or not on the set of natural numbers. Suppose I have 3 hash 4. That would give me 3 minus 4, which is minus 1, which does not belong to the set of natural numbers. Hence, this operation A minus B is not binary. So this is how we check whether a certain operation is binary or not. Let's move on to exercise 1.4. This is on page 24 in the textbook. The first question deals with something being binary or not. The question says, determine whether or not each of the definition of star, the operator, gives a binary operation. In the event that the star is not a binary operation, give a justification for this. Now these are the easiest 1-mark questions you can get. Let us take a case, the first case, Z plus. Z plus means positive integers. Now here A star B is defined as A minus B. The question is, on a set of positive integers, is this definition a binary operation? And the answer is no. Let us take a set 3 star 5. I'm going to get 3 minus 5, which is minus 2. As you can see, this does not belong to Z plus. Hence, it is not binary. So, even if there is one pair which does not belong to the original set here is Z plus, positive integers, then it is not binary. Let's take the second example. Here you have again Z plus, but A star B is defined as AB. Now when you multiply two integers, let's take for example 2 star 3. 2 into 3 with 6, again it belongs to Z plus. When you multiply any two positive integers, you are going to get an integer. Hence, this operation is a binary operation. The first one is not binary, second one is binary. Let's take the third example. In the third example, it is on R, real numbers. Now, real numbers are all numbers except square root of negative numbers. So, imagine you have a real number, any real number. This will include fractions, this will include natural numbers, rational numbers, irrational numbers, negative numbers, zero, anything at all. So, the set of real numbers A star B is equal to AB square. Let's take say 2 star 3. This would give me 2 into 3 square, naturally a real number. Hence, this is a binary operation. You take any pair, you are always going to get a real number if you take A into B square. Any pair will give you real numbers. Hence, it is a binary operation. On the other hand, the fourth question, you have on Z plus, you have A star B, which is modulus of A minus B. Now this would give any positive integers you take, you're going to get 3 minus 5. Modulus of 3 minus 5 is plus 2. It's plus 2 because of these two sturdy lines, the modulus sign, which naturally belongs to Z plus. Hence, it is a binary operation. Fifth one says Z plus again, A star B is A. Now this is also binary because when you take 3 star 2 would give you 3, 7 star 10 would give you 7. So that since this is a positive integer, the output will also be a positive integer. So whenever the output belongs to the original set, that means it is a binary operation. Now, let us take another example which is not there in the book. Suppose I take A star B, which is A to the power of B, on a set of real numbers. Is this binary? Think about it. Is this binary? A star B is A to the power of B. That means you take any pair of A and B real numbers, will you always get a real number? And the answer is no. Because if I take A as minus 1 and B as half, I am going to get minus 1 to the power of half, which is square root of minus 1, which is not a real number. Hence, on the set of real numbers, this is not binary. However, the same thing is binary if you take A star B, A raised to B on natural numbers. Because A raised to B, when A and B both are natural number, it will always be a natural number. You can think about that. However, it will not be binary on a set of integers. Simply because 3 star minus 2 is 3 raised to minus 2 does not belong to Z plus. So that's the way we check for binary. Let me give you another example to check whether something is binary. For example, suppose you have a set of students here. Imagine we have a class of students. Say I have these students Eben, B for Benson, C for Christina. A set of students in my class A, B, C, D, D for Derek, E for Ishwar, F for Fahad, G for Ganesh, H for Harmeet Singh, I for Indira, J for Johanna, and so on. Say, so many set of students I have. Now when I take, imagine the students are all arranged in order of their weights, meaning the heaviest is Eben. Eben weighs say 72 kgs, Benson weighs 68 kgs, 67 kgs, Derek weighs 64 kgs, 62 kgs, 60, 58, 54, 52 and 50. Imagine these are their weights. Now when you take S cross S, it will give you a set of all ordered pairs, Eben and Eben, Eben and Benson, Christina and Derek, and so on. So in the original set we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we will have 100 elements in this set. Imagine we take S cross S and I am giving an operation A star B, the heavier of the two. So that means Eben star Benson would give me Eben. If I take Harmeet star Johanna, I will get Harmeet because Harmeet is heavier of the two. If I take Ishwar star Indira, I would get Ishwar. So when I take the heavier of the two, this is naturally a binary operation simply because the output will always belong to the original set. So this is how we check whether something is a binary operation or not. Now an operation, if it is any operation, if A star B is equal to B star A, then the operation is commutative. So that's what is called as a commutative operation. On the other hand, if A star B star C is A star B star C, then it is associative. So in the second question, if you want to check whether it is commutative, say for example on the set Z, you have A star B is A minus B. Now you can see that B star A is B minus A, and therefore A star B is not equal to B star A, hence it is not commutative. Is it associative? Let us check. If A star B star C, A star B is A minus B star C, which is A minus B minus C. On the other hand, A star bracket B star C would be A star B minus C, which is A minus bracket B minus C, which is A minus B plus C. As you can see, these two are not equal. Hence, this is not associative. So this is the way of checking whether something is associative or commutative. Thank you for watching. This concludes lecture 1.